Hello, everyone. So I know we are still a bit early, but again, I would like to utilize this time to take any question. Um, if you have questions, please feel free to drop these in the chat. Today's slides, I posted them on Avenue for those who would like to look into them while in lecture. Yeah, Ian, this has been asked like hundreds times. Please ignore the autograder, right? If you pass all the tests locally in your Eclipse, that's okay. We have a problem with auto-grading currently, so don't worry about it. But in question 3, 8.9.5 equals to GBA of 4 or 3. If not specified, then it's okay to do either, right? And I know that the question was loose in these 8G grades. I would say something you can try is maybe you round up, which is usually what's happening in real life. So round up the grade such that if it's like 89.5, for example, it would be 90, and then it would be 4, right? Yeah. No, you don't need tests for question 1 and 5. You can add if you would like, but they don't add much because question 1 and 5 take no input. Which means all the tests should be the same. So we already have tests for those. So if you don't add, that's no problem. But if you'd like to add, again, it's just a redundancy check. Okay. So for question 3, change every input to integer roundup. Well, as I said, it's up to you, right? But if you round everything up, you can do that if you would like. This is a way. The question didn't really specify those 8G cases, so you are free to do that if you would like. Jiao Yang, do we need to make a different code for question 7? A and B, I guess this is what you mean. You are not, so okay, you don't have to, but you are recommended to do so. So what I mean is the general case, which is 7B, can still apply to 7A, which is a 7-digit case, because it's a general case, right? But the purpose of having A and B is to first make you think of a special case, which is 7-digit. You can utilize this limitation of the user to see how you can better do it. And then generalize your model to include all the digits, right? So this is how people usually think of different problems or algorithms in real life, is you see what might be special cases that might make it easy for you, and then you build on top of that. So from the grades point of view, no, you can use the general case for both. But from the exercise point of view, and practice for you and general like programming skill, I would recommend that you do both differently. Question 5 says we need to print all the triples, but we are not allowed to use print. Yes, don't use, as I said in the announcement and the email that I sent to everyone, don't use printf at all, even if you are asked in the question to do so. Thanks. Thanks, Akshat. I never tried it, in fact, but maybe I can give it a look. Okay, so what is the time right now? So we still have like 2-3 minutes. So please let me know if you have questions. And as I said, the slides for today are already posted on Avenue. Today's topic is one of the important topics in C and in algorithms in general. So if I guess it's an important lecture. Why I got a test result expected 3.6, but was 3. Hanix, yeah, that's a very specific question. So I believe why you got that, because that means you implemented it wrong, right? But what I would say is if you think it's correct and you're not sure what's going on, maybe you can come in office hours and we can look into it together. Can we use Power for the lab? So I addressed this in office hours and in tutorial as well. I would say don't do that. So for multiple reasons. One of them is Power in math library in C standard library is expecting two double inputs. Good. But this question that you're referring to, which I believe is the Pythagorean triples, is taking int as input. So that means a casting would happen if you call this function. And in some of the implementations in your machines, I have seen this a couple of times at least for students. In some of these implementations, they give the wrong results, right? So I would say please don't use the Power for this lab, and you don't have to, in fact, right? If you're going to say that a positive integer is given as an input, should we handle the possibility of negative integer as input, or should we assume that only opposite? Okay, Cham, that's a good question, and I will conclude with this and then start. So if the question is saying that you should expect a positive integer, that means you don't necessarily need to check whether the user input is something that is outside of that range. So it's safe to assume that you only get positive integers. But this is what is required for the lab grade. But for general good programming practice, I would say it's always good to have your guard against bad user inputs. So if you do this check at the beginning of your function to check whether the number is positive or negative, and then if it's negative, you do something, then it's a good practice, right? Okay, thanks. So let's then start. As I said, the slides for today's lecture is already on Avenue, and I will do my best to hop between it. It has been a long time since we did something on online GDB, and we practiced together. So I will do my best today to see if the time fits. We can try some of the examples together. So what are we doing today, and how it fits within the general plan we have? So far, we covered some of the C basics, and then we talked about arrays, and then functions, and then how to deal with arrays and functions. And then we started by some general practice. Make sure you guys refresh or revisit the concepts you have from Python, including loops, conditions, and all these things. And then in the last couple or three lectures, we kind of took a deep dive into the details of C, including like what are the details of dealing with arrays, what are the general rules, functions, the same thing, different types, how we deal with them. Good. One of the most important topics in C is strings, right? And why it's important in C and in programming in general. So first of all, it's important in programming in general because strings span, I would say, some of the most important applications in real life. Translation, text recognition, different things like natural language processing. So many of the problem, like if you take like a more fancy thing, you also have the DNA analysis, right? So all of, because DNA is kind of a stream or sequence of strings, right? So dealing with the strings is very important in real life. This is why it's very important. The second thing is why especially important in C, because surprisingly, C doesn't have an inherent type that is called string. It's not like most of other programming languages where you deal naturally with the strings. So you have to pay attention. You have to have some kind of a little bit more struggle when dealing with the strings in C compared to other languages, as we will see in this lecture. Good. So what we have covered so far is, let me see if you can still see me while typing here. So what we have covered so far is characters, right? And characters are the natural type of dealing with what you type in your keyboard, right? And we said characters are of single byte, and they are inherently, so inside the C, they are the integer value of the character you entered in the keyboard, right? And we said this is according to the ASCII representation. Good. We have covered all of this, and this is the ASCII table we have seen before. We said every character you have in your keyboard has an associated value of int, and we tried some examples. Here, for example, we say that if integer value is 70, so for example, if you add f plus something and then you cast the result into an int, it will give you the int representation of the result. Good. And then also we said there are some kind of special characters you deal with, like the new line, the tab, the space, and these things. But we have never seen strings so far in C, right? So we didn't try something like this, like writing a string between double quotes and say hello, for example, or anything, right? Why? Because as I said, string is not an inherent type in C, and we have to have some kind of additional knowledge to be able to deal with it. The general rule that you will see consistent across any C programming course, like including to SH4, is that strings are nothing other than arrays of characters. What I mean by this is the compiler is dealing with strings as arrays of characters, and you don't have a direct way of defining a string. There are some helping libraries that can allow you to define string, etc., but it's building on top of that string array. Okay, I'm back. Okay. Okay, so laptop is back. Good. So the thing is, assume we didn't mention the word string at all, then you can define very easily an array of any type, including array of characters, and then you access this as if you access a normal array, correct? The only thing that C adds on top of that is you need to make the last element of your array as a null character. And by doing this, we'll see now what we mean by null character. But this is the main difference that you will see between a string and a regular array, including even array of characters, is if you terminate your array of characters by a null character, which is this one here, then C makes it easier for you to deal with this array as if it's one entity, which is a string, right? So let's have some examples to make this clear. For example, here, I'm defining a character array. Again, you guys have seen arrays, see how we initialize arrays before. The only thing here is instead of defining this as int, we are defining this as a character. And we have 1, 2, 3, 4, 5 elements, right? So this is a normal array, right? To make this a string in C, the only thing you add is you have to make your last character here a null character. Good. And we call the second one here a string, but this one is a normal array of characters. This is the only difference between strings and normal array characters in C. Good. So this null character is used by the programming language to indicate termination, right? What we mean is, how do you know that your string is done? Assume I want to define a string, and this string is defined in a way that it's multiple characters back to back in memory. How would I know as a compiler that here is my string is done, everything afterwards is not related to this string, right? This is the termination symbol, which is the null character. So if the compiler hits the null character, it knows that whatever was before is a single string, correct? So it marks the end of your string. By doing this, you can now define your array of characters as a normal string, as you do in Python, for example. You don't need to initialize it in the normal way of defining or initializing any normal array. So you just can simply do that. If you do this, this will end up or being translated by the compiler exactly as if you initialize element by element, and then you make the last element as a null character. Good. What does it mean? It means if you want to define a string that has 5 characters, like hello, for example, what is the size you need for your array? It has to be 6. The reason is you always have a hidden character, which is the null one you have to terminate with, right? So we call this, the string itself has a size of 5 characters, but the array has to include 6 elements because it's the 5 plus your termination. Good? So let's see some examples. Assume I want to go through a string. I want to go through the string one by one, like iterate through the string. What you would do, you can either use a for loop or while loop. And then how would you know you are done with your character? Let's try this together with online GTB. Hopefully we have enough time to do these things. So let me see here. I can share. Okay, so I share screen. Okay, so let's do that. Let's define a character array that I call, I don't know, let's call it B to continue with the example we have. And then this B would be initialized to, you can either do this, or it would be equivalent if we do this. B, L, U, then E, and then a null character. Good? And then if I want to iterate through this, what I would do, let's start with a for loop. So I would do a for loop. First of all, I need to have my index for the for loop. So int I, and then I say for I equals 0. And then I need some condition here to make sure I terminate my array. And then afterwards, I go through the elements one by one, right? We will come into this condition afterwards. And then I do my processing. For example, here, maybe I can just print f, what I'm doing, print f the character that I read, right? Which is bi, right? And that's it. Maybe I just print it in a new line to make it better readable. And good, done. So now I want something here as a condition to know that I'm done with my array of characters. So if you know this size, if you know the size of your string by default, for example, here I know that my array is 1, 2, 3, 4, then you would say I less than 4. But generally, you deal with strings as if they are coming streams. The user is providing them, so you don't know their exact size. So what you can do instead is to say, I'm going to loop until I hit the null character, right? Because we said that the convention in C for strings is you end up with a null character. And here comes your condition. I hope you guys are able to, let me, making this bigger will help.
I think the last character in the array should be \0, not \n.
Ah, it's a new line, sorry. It's, thank you. Good, yeah, that's great. This is your null character, not the new line character. So by doing this, this is the code that you use to know that you have hit your end of the string. So if we try to run this, it's running because I made it big so I don't see. It's too slow. Oh, come on. Okay, so we printed them one by one, right? So this is one of the main things you need to understand about strings in C. Good. So let me see if there are questions, and then we will continue. For sure, it should be like the null character. It was just like a mistake. I wasn't paying attention. Yeah, and how is the slide of defining and initializing strings do both with the same work the same way? Yes, if you are referring to, for example, hello, and then like similar to what we have done here, this or this, they are exactly the same. That's correct. Jack, why do you need to do a for loop at all to print the string? What should happen? You just print F, C, and B. Okay, that's an excellent question that I'd like to address. So he's saying, if B is a string, why I just don't print the string? First of all, the specifier or the placeholder you have here, which is %C, is only for one character, a single character, right? So you cannot print a whole string using that. The second thing is, B itself, the array name, if you remember from our array lecture, it's the address of the first element. So you cannot directly use it in any operation, at least until now, right? Which means if you try to print this, B is an address. It's in fact not a string, right? So you still need this. This is one problem why string, one problem that is a result of why C doesn't have types that are called string. So it's not a single variable, it's still an array. Steven, anyone know if you are allowed to use the power function? Okay, I think this questions.
Hey, sir, you cut out while you were answering my question. Do you mind repeating the answer?
Sure, thank you. So what I was saying is two things. The first one is this specifier, which is %C, is for only a single character. So you cannot use it to print an array or a string. We will see now there is another specifier later in the lecture that you can use to print a string. But this is one thing. The second thing is B. If you use B as you wish, this is an array, right? So if you try it, let's run it, and I want you to see it. So if you try this, B, you see here. First of all, this expects an argument of type int because the character is an int at the end, as we said, but it gets a character of, what is this? This is a pointer, right? Which means it's an address. Why? Because you fit B. We said from the array lectures is the array name is an address of the first element. So you are providing an address, not the string itself, right? Good. Hopefully this answers your question. Later we will see there are easier ways of building on top of this to print the string as a whole, but not in the way of array of characters. Good.
Thank you.
Thanks. Aaron, are there any reserved words in C like str in Python? Not str, but by some helping libraries that are building on top of C, you might have, so we have a string.h file that we will see at the end of the lecture, and it has some utility functions for dealing with the strings. So a word string, I believe, is a reserved word in C, so you cannot use. Good, so let's go back to the lecture. Before this, what if I want to do this using a for loop, right? Because this is what is the lecture about. So simply now you only do while, and then your B of I is not the null, and then you remove the for loop from here, but you need I here to be 0 as a start point, and then you increase I here, right? Similarly, we have done this before, like how to translate a for loop into while loop, doing the same thing, right? But we need the while for further examples. That's why it's good to try it with you. Good, so let's go back to the slides. Good, so we have done this. We have seen the condition here, the one that we have been talking about.
Quick question.
Go ahead.
In the loop you just wrote in GDB, the while loop, you said while B of I is not equal to 0. So does that mean that the null
no, it shouldn't be 0. It shouldn't be. Okay, that's a good point. I don't want to confuse you.
I know,
right?
but it still worked. So is that because the null character is equivalent to false?
Yes, that's correct. I will come into this now, but yeah, it's a good catch, Arjun. But again, like the new character things. So, but let's not confuse ourselves for now. Let's just talk about the null character itself. We will see about this equivalence between the 0 value or false, as you said, and the null character. But you are correct.
Okay.
Thanks.
Okay.
So this is a while example that we have done. So what if I want to build on top of that, and I want to compute the size of the array, right? Which is, in other words, how many characters you have in your string, right? Then instead of just printing it out, you keep increasing your size one by one, right? And then at the end, you print the size, right? So if we go back to the online GDB, here, if my size is, so what I want to do at the end, let's just keep it as it is, print f, and then I will do the size equal, and then here this is an int, so it's d, and then I, right? I just run that. Okay. So you get a size of 4 because you have blue is 1, 2, 3, 4, right? So you just go through your string one by one. You have a counter that keeps increasing until you hit the null character at the end. You stop your loop and then you print the size, right? So this is how you can come up with the size of an array. As you might imagine, for example, if you go to Lead Code, if you are preparing for an internship, you find like a complete section for string manipulation for algorithmic questions, right? This kind of gives you an indication how dealing with strings in different ways is very important. Okay, we have done the size. Find the number of occurrences. Okay, so one additional thing, what if I want now to not just count the array elements or the string number of characters, I want to find specific occurrences there. So look for M or I or any character, right? So what you can do is now you a little bit complicate your example, right? So if I keep hopping, but I guess it's useful to see things practically. So for example, if I'm looking, I want to count how many L I have here, right? So instead of doing this and just printing, I would say if bi, which is the element that I'm in right now, is equal to, I'm looking for what? L, right? Let's say L. Then you have a separate counter. So let's call this count equals 0. And then you increase your count. And then at the end, you print the size and the number of occurrences of letter L is, and then you just print the count. What I have done here, so I just added a little bit more complexity into the example. I'm looking for a certain character. Here it's L, it can be anything. And I have a separate counter for that to increase each time you find it, and then at the end I print it. Why I didn't have my count as the same counter as my iteration loop index? Because it's a different count, right? It has a different purpose. It counts different things, only the occurrences of L, not just how many iterations I go through, right? So if you run this, you should get count as 1, right? So here size is 4 and the number of occurrences of letter L is 1, right? As you can imagine, if I add different things here and run, you get 6 because we added 6 L's right now, right? This makes sense? Is there any question? Let me see if there are questions here. Okay, no questions. Good. So what else? So we have already found the number of occurrences. Good. What if I want to find the number of occurrences, but whether it's written as like a small letter or capital letter? So simply you just build on top of your condition here, right? So you just have bi, then whether it's like this or like that, right? So you can complicate your condition as you wish, right? And then here, if we added few else like this, it should give you the sum of both, right? Aaron, can we pass a character array as a function parameter. We will come into this, Aaron, in the lecture. So we didn't deal with arrays of characters or strings into functions, but we have a separate section for this in the lecture. What about string length function? Okay, good. So this is one of the helper functions in the string header file in C. Let's not do this for now, right? All what we are doing is without using any string helper functions. Good. So what are the, instead of keep hopping on and off, what I will do is I look into the slides on my tablet and then try to build on the examples if we have here. Passing a string to a function. Okay, that was directly what we have after. So what we want to do is assume I want to write a function that takes as an input a string and then reverses this string, right? So I want to like read the string, see how it looks, and then reverse it. Similar to what you have done in one of the lab questions, you take an integer and then you print it in the reversed order, right? So first of all, how would I take a string as an input to a function? We said before, the general rule is that a string is nothing other than a character array. So what you can do is simply write, let's call this reverse string function, and it would take a character array that I would call, I don't know, X or input string. Let's call this X, right? And then we should build up the reverse here, right? So let's think one by one how I would do this, right? How I would reverse my string array. Is there any idea how the algorithm, where should we start from? So I got a string as an input. How would I would reverse it? The simplest solution, I guess we have seen this in yesterday's lecture, the simple in the transpose, matrix transpose example, the simplest solution is to define another string of the same size, right? And then just copy all the elements in the reverse order, right? What was the problem with this in the transpose matrix, which is also here, is now you kind of take another space, right? Like you define another array, so you are wasting the memory space. So it's not space efficient, right? Let's look into the examples. Decreasing for loop because you want to start from the end. That's correct. Use a temp variable when switching. Exactly, Nicole. Aaron, what is the difference between null constant and null in C? I will come into this, Aaron, for now. Thank you. So yeah, can someone kind of develop the ideas as well how to do this? So assume I do what Arjun and Nicole both kind of suggested different steps. So I would say I'm looping through, first of all, I'm encountered with the problems that if I want, Arjun said, let's do a reverse order for loop. But I don't have the array size, right? So I cannot even go to the end. I don't have n right now, right? After determining the size string and use the way of the yesterday swap. Yeah, and how? First find the length of the string mark. Good, so you guys are moving forward, that's correct. So first thing, I need to determine the size of the array. So I do this through something similar to the while loop that I have here. I simply define this, and then until it's not this, I increase my I, and then at the end, maybe I call this size if you wish, size, and then size, and then size. So the first step is get the size, right? So at the end, once you are here, size is holding the size. So we have the size, good. Then taking the further steps, you said I want to start from the end and then swap stuff, right? So by using a temp variable, for example, good. So again, what to do? So in one of the examples we have tried in the arrays, if I recall, it was in the tutorial 3, we said maybe an efficient way is to have 2 pointers or 2 indices, one at the beginning, one at the end, and then use these to move forward and then swap, right? Another way is you just given the size, I will do this. I would say for int I, oh, I don't define the I inside, so I say int I, then I equals 0, and then some condition here that I will ask you about, and then I increase. And each time I do this, I want to swap the first element with the last. So I know that always the last would be the size minus I, right? Because I keep moving forward. So I would say, I need the swap here. So let's call this character temp. And I would say, let the temp be your xi, and then put the x size minus I into xi, and then just put the x, so I do the other way around, and this should be xi equal that, and then x size minus I should equal the temp. So all these three lines are just the very simple swap stuff. You can even put this in a separate function, call it swap, right? By doing this, we have taken, if you have I equals 0, then you started from the beginning, so you are swapping the beginning, and size minus I is size minus 0, which is your fourth element, right? But if I'm doing this, there is one thing wrong, right? I'm missing one thing, right? What is this? Like this size minus I is not completely correct. Gotung is talking about when I should stop, about the condition. Oh, -1. That's correct, Muhammad and Aaron. Because size, think about the blue example we have seen here. This blue has the size of, it has given me the size of 4, right? But if you look into the elements, it's 0, 1, 2, 3. So it should be size -1, right? So I do that. And then this is your temp. Okay, good. And then here it should be -1. Then about the condition, so we still have to figure out what is this condition. Let me see who said that here to give him some credit. So that's Gotung. So he said your condition should be the half of the array, right? Because if you keep swapping stuff, it's similar to the transpose yesterday. You should take the half. Otherwise, you keep swapping and you turn back to the original array, right? So you'd say I should be until you reach the half. But what is the half? It's size -1/2, right? So if we take an example, size, so if I have 0, 1, 2, 3, I want to stop at 1, which is 4 minus 1, 3/2. It gives you 1 because this is an integer division. Good. So by doing this, you have swapped your array without using another array, right? A simpler solution would be just as I said, like define another array. Once you find the size, keep pushing things, but this is wasting space, right? And then you don't need to return anything, but why? Why I don't need to return anything? This function is just returning void. Does that mean whatever I do here does not reflect in the main? What do you think? You pass an array and how? Correct. So no need for return. Correct. String is passed by reference. Correct. You modify the given array. Aaron, correct. All of this is correct. What we said before is when you pass an input as an array without using the constant specifier, then the array will be modified by default inside the function and it will reflect in the caller. Good. So let's see if this works, right? So here I'm defining B as blue, and then I'm just calling, let's say I want to, okay, so what I can do is while I'm going through the size, I don't need the count now. I'll just call reverse, what did we call it? Reverse string, and then I call it on B, and then I'm going to print B, right? I don't need this, and then I would just say all of this is not needed, in fact, and just print F. And then this is character, and then you have BI here. Good. This makes sense. Hopefully, yes. And this, let's run this and see what happens. Okay, B size undeclared B. Yeah, this should be X, right? I just copied and pasted. Okay. Okay, so you see, oh, but things are not in really. So it's ELUB. but this should be okay. There is one thing missing here because it's not completely the reverse, right? So what's going on? Can someone highlight what's going on? Size over 2. That means we didn't. So the main thing is we didn't reverse these two. Here I is 0. Here I is 1, right? Am I considering, oh, it should be equal, right? Because I want this to include 1. Or as people are saying, size over 2, right? But I would say this is a more kind of a formal thing. You want to stop at this one. Is it running or what's going on? Okay, it's taking some time. So let's hop back to the slides until we see the results. Now, interesting. Okay, run. Okay, so yes, we share here. Okay, so yeah, so as you guys said, the steps are first to find the size of the array. If you do size minus 1, it has to be less than or equal. Yes, this is what we modified. That's correct. Thank you. So first of all, we find the size and then reverse the string and then we are done. So how to find the size? We have done this already before. And then to reverse, here in the example in the lecture, we are stopping at size over 2 and it's less than, so here. Or you do I less than or equal to size minus 1 over 2, right? And then you do the swap. As I said, these 3 lines you can even define in a separate function and you can call it swap, right? And then you are done. Are we good? Do you have any questions? Your GDB, okay, so it might be a problem with the GDB itself, Nicole, or maybe hundreds of us are trying to access it at the same time, but I don't know what kind of server that it doesn't handle 100 users instant. So that's okay. Okay, some of the tricks. So previously we had this question of I want to deal with the string as a whole. Like it's okay, it's an array of characters, but is there an easier way of dealing with either getting DDoS? Not for 100 users, Harun, but yeah, okay. So the thing is, if you want to deal with a string as a whole, for example, read a string from the screen or print it to the screen without doing this for loop. So you can use another specifier that is called %s, right? And this is special for dealing with strings in C, right? The string has to be read into a character array. So the way you take it is read into a character array, and it has to hold all the size of things you are reading from the scanf, including the termination character. So one example here is, what if you want to specify something like this? You defined a character array of size 20, and then you are asking the user to enter a string, and then you read this as once. Now, by doing this, you are able to deal with the character array as if it's a single variable, it's a string, and then you read it as a whole, right? Good. So one problem with this is you didn't specify how many characters you would read, right? So for example, this array has a size of 20, but if the user inputs, again, it's a bad user behavior. If it inputs something like, okay, mine online GDB already done, but that's okay. So if you read something from the user, and the user inputs 40 characters, you don't guard yourself against this bad behavior. One way of doing this in strings is to specify how many characters this string will include before the S. For example, if you say it's %5s, then you know that at most the string would read 5 characters, right? So even if the user inputs something afterwards, it's not going to be accepted. Good. And this was for scanf. For printf, you have exactly the same thing. If you do this, if you define your character array, you can simply just print it using the specifier s. I hope whoever who like asked this like 10 minutes ago, now he gets the answer, right? You cannot use the specifier c for the character. You have to use the one for the string. Good. Okay. Well, one interesting thing that Arjun raised earlier is, let's see, I do something like the following, and this is one of the tricks that I sometimes I give in exams, is assume I define my array of characters to be like this, Canada, right? And then I print it. So great, it prints, right? How would, maybe the question that leads to this, understand what's going on here, is the question, how does the printf function knows when you are done with your string? You don't pass the string size, right? How would printf know where it should stop printing? What do you think? This happens when it encounters the null character, correct, Nicole? And once it finds this, it knows that string is done because null character is a termination. So if you print this here, it will go Canada until it reaches like the null character, and then it prints Canada correctly. But at a certain point, if you in verbose overwrite one of the characters in the text or in the string to be 0, and then you try to print, 0 is going to be interpreted for a character. So if you look into, let's go back to our ASCII table here. Look here. You fit, so first of all, when you say something like, I don't know, A3, and this was a character equals 0. This is int, right? This is character. Good? What do we do here? What is this called? It's called casting, right? And we have seen this before. So if you cast, what would happen is you go to the, like the compiler or the hardware would go to the ASCII table and see the character representation of 0 and put it in the character array, which happens to be the null character, right? So this line here, what it does, it just casts an int into a character because this is an array of characters, and it's going to be replaced by its character representation, which is the null character. So when you try to print, again, printf knows nothing at all. It keeps printing your characters until it hits a null character, and then it stops, right? So it only prints CAN, right? Hopefully that's clear. If you have questions, please let me know. Good. Before we jump there, let me see if there are questions. Similarly to how inputting a 0 will trigger a null character, could you manually input false to elicit the same response? I hope this makes sense. I see what you mean, Jack, but there is no false. Remember, there is no false in C, right? There is no Boolean character. Sorry, there is no Boolean type, which means how you even enter false, right? Maybe within a false condition. For example, you say not 1. So let me give you one example here. If I write this like this, string 3 equal 4, this would have exactly the same result because 3 equal 4 is a condition. It evaluates to false. False in C is 0, and it adds exactly as if you entered 0. I hope this is kind of what you are looking for. Sagnan, when you find the size of the array, does the null character get included in the size? It depends on how you find the size. If you do the while or the for iteration we do until we hit the null character, then it's not included. But generally, the size of the array should hold all elements, including the null character. So for example, if here Canada 1, 2, 3, 4, 5, 6, if you calculate the size, so let's differentiate between two things, the actual size and the capacity or the length, right? Here, you define the length of 20 already, but this has 1, 2, 3, 4, 5, 6 valid characters in addition to the null character. So at least to be able to hold Canada in an array, it should have at least a size of 7, right? Aaron, it will return the ASCII representation of 1 in character. I guess you are answering Karina's question. So if you did string 3 equal 1, yes, it will return. Yeah, that's correct, Aaron. It will return the ASCII representation of the 1 value. Mark, does C automatically fill in empty cells in a character array with the null character, like if you access string 8 while it's equal? Okay, that's an excellent question. Let me think. I would say yes, because characters of array, all the rules we have discussed in yesterday's lecture applies to here, including that if you use this for initialization, if you use this type for initialization, the remaining elements are set to 0, right? Which is in characters like null, right? Okay, good. How much time we have left? Because usually I take you over time. We still have some 6 minutes, good. So some kind of functions that deal with characters and strings in C. So we have a function that is called gets. So far we have dealing with screen as scanf to read something from the screen or the user, and printf to print something into the screen. We also have, for characters especially or strings, we have gets and puts, right? Gets similar to scanf, you read characters from the screen, and puts something into the screen. The way gets works, that it takes character array, a variable you define, to put whatever you read into this array. And then puts, it's like printf, you print whatever string you have here. Let's see one example. And by the way, you can replace gets and puts by printf scanf completely, right? As you can see, gets and puts is kind of a special case of printf and scanf, but only for characters and strings. So here I'm defining a character array of size 20. I'm asking the user to input something like five characters, for example, and then I try gets A. That means whatever the user is inputting, it will be in the A array, right? And then here I'm using printf to print certain characters of that array, and then also I'm using putf to print it, right? So you know what, maybe if we still have online GDB functional, I might try this quickly with you. So let's say this. I'm defining this example to have, I don't like 20. And then now I don't need this reverse stuff. I want to use gets, but maybe I'll ask the user first to input something. Please input a string of some number of characters, 5, 10, whatever. Then new line. Then gets in B. So B here is passed as an input parameter such that gets can modify exactly as you are passing an array to scanf. And then now let's say I do puts B, right? Then all of this is not needed. Then I will just run. Gets is deprecated. Okay, thank you. Please input a string of 5 characters. I don't know, rats. It returns rats, right? So if you write anything here less than the size of this, it would print it. One thing that I would like to pay your attention to is what if, for example, assume here I define the size to be 5, and then I run, and then I input something like very long, I know, McMaster University, something that is going to exceed the array limit. Good. It prints it back, but it gives you a problem and termination because you have a memory problem. Here it says stack smashing detected. What does it mean? It means that you are trying to access a memory that is not allocated to your program, right? Which means you might be attacking the hardware, or you might be doing something suspicious, right? So why this is happening in C? Because again, C, if you remember from arrays, it doesn't have a array boundary checking, right? So the user, if it inputs something, it will get stored in the memory, even if the user does not have right to do so, because here we only have a size of 5 and we entered, I don't know, like 10 or maybe more than 10 characters, but it operates, right? And it operates in a risky way, because if you overwrite something in the memory, it might get even your system crashed, right? Question, what is the point of gets and puts if we already have scanf? So it's, okay, to answer your question, Karina, what if the point of having a while loop if you can do everything using a for loop, right? Usually programming languages are rich, right? They are not, how would I would say this? They are not only sufficient to do the minimal function. So you have different, you can do the things in a different way, right? As if, so we get, so Aaron, that's not completely correct, because in scanf and printf, as you have seen in, I guess, the previous couple of slides, you can directly print the string using the S specifier without doing the loop, right? Reja, so we use gets puts when you are not using loops. I'm not sure what you mean, but I can, okay, so let's do this, okay? Maybe you guys, this will help you understand. So scanf, I'll do this, S, and then B. Good. Then I run. And then I enter something like, I don't know, Yonev. You get it, right? So here I use scanf without any loop as well, but I used the string specifier, right? So it has the loop internally, right? Aaron, is C99 is giving you invalid for gets because it's deprecated, right? Yeah, so it's deprecated. What means by deprecated is it's already overwritten in C more modern versions where you can replace it with other things, including scanf and printf, the S specifier, right? Harun, why do you not put and B for scanf? That's a good question, Harun, because B is an array, right? And we said arrays by default are passed by reference. You don't need the address thing. In fact, B itself, the name of the array, is an address on its own, right? So it already has this and by default, right? Okay, let's go back to the slides to make sure we finish before the time, because we are already 1 minute past. So here, good. This is one option, I think, is how to format the output of your string. I will leave it for you to read. Just a couple of things to mention before the end of the lecture is you have a character handling library and a string handling library in C, right? The first one is the character handling library, and you can use this by including the header file C type or character type, right? It has some very useful functions. For example, it has functions to detect whether your input character is digit or alpha or lower capital or lowercase or upper capital or uppercase, right? Or even like to lower or to upper. So it allows you to manipulate your characters in a certain way or check their type, right? And then how this is useful. I'll give you one practical example. And in fact, this is something you can try as a practice for this lecture. Assume you are building, I don't know, a website or some kind of server that asks the user to input a password, right? And you don't want, for example, or a username, and you don't want the username to start with a character that is a digit or a special character. It has to be only start with a letter, right? So what you can do is take this first character and use one of these functions. For example, you check if it's digit or it's a special character or something of that sort. Then you give him an error or a warning, right? This is how you would handle things. If it's a Bing code, it has to be only digit. Then you can have to you can test your characters, including the isDigit function. This is in the C string.h. There is another one, which is string.h header file, which is for strings, right? It has some of the string manipulation functions for you. For example, we have implemented ourselves a function to get the string length or size. it already has a built-in function. I believe one of you already mentioned this at the beginning of the lecture. It also have a version of scanf and printf for streaming like strings, special kind of strings to deal with it. But this is a kind of an optional thing. So one thing to mention, and then I'm done because we are over time by 4 minutes. If you are asked in the exam to implement, for example, isDigit function, or to detect whether a character is digit or exam or lab or anything, I don't mean particularly exam, right? Don't use the string.h if you are asked to implement one of its own functions, because it makes no sense. If I'm asking you, for example, to detect whether this character is a digit, and then you just write isDigit by calling string.h, then you didn't really implement it, right? This is one thing. The second thing is, in labs or exams, if you are asked not to use any function of the string.h or the math.h or whatever it is, then please don't do so. Because many of you, for example, had the question of, can we use the power function? Aside from the problems I mentioned that the power can cause, but you can see in the lab 1 document at the beginning that it states you are only allowed to use printf and scanf, which means all the math library functions you cannot use, right? So I hope this clarifies some of the concerns that you might have. I'm done for today, but I will stay for a few minutes to take questions. So thank you. And I will do my best to upload this lecture and yesterday lecture by today. Aaron, did you not? I think Karina. So how is scanf different than gets? Karina, so scanf is different because it's general. It can read strings by using the S specifier, but it can also read characters by the seek specifier. It can read decimals, doubles, but gets is only for characters, right? And as you have seen from the example we run in online GDB, is that gets is already deprecated, which means here is what I believe is the case. Gets, so scanf in very old C versions, they weren't able to handle strings, and they needed gets and puts to do this. But recently, scanf had this S specifier, which means you don't need gets and puts. This is why it's deprecated, right? Arjun, the character handling functions take integers as input. Do we have to cast? No, they take. Okay, because that's a good thing. So here it said int, but mainly because characters are int anyway, so you don't need to do casting explicit. Like the casting is done by default, right? Jack, why does printf print Canada and not Cana? Because I thought indicating a number between this. That's why the number output. Yes, but see, Jack, like it's you don't put the 4 before the first S, which means first you will print a string, and then. So let me see the example you are referring to, just to make sure I understand what you're asking about. I guess this is in the formatting thing. Here. Okay, so C. So it's taken into account only if it indicates field larger than the number of characters in the string. Precision indicates the number of characters to be outputted. Good. So if you read these 2 lines here, it tells you that for the printf it's different than scanf. For the printf, this specifier will only be taken into account if the field is larger than the number of characters. For example, in the third case, where we have 12s, while Canada is only 6, you had here, you had 6 spaces at the beginning. But in the second one, where we had 4s, 4 is less than 6, then it's just ignored, right? If you want to print only 4 characters, then you would use the precision, this one, not the field size, right? Which is the first one. I hope this answers your question.
Yeah, thank you.
Perfect, thank you. Aaron, so that for sake of the exam, do we use old version of C or new version of C? Thanks, Aaron, for this. So as we said at the beginning, I guess the first lecture or second lecture, here we're assuming first of all, I'm kind of lean in that. Like, if it's correct in one of the versions, I'm not going to penalize you. Just to be very clear, right? If it's correct, because what we care about is doing some practical programming rather than caring about what version is doing what. But the second thing is, if you want the rule is we are using C98 as a convention here, and by doing this, no, my laptop. Okay, so by doing this, we just put aside some of these problems. So, for example, if you use gets or puts, that's okay, because it's supported in the old version. I'm not going to say it's deprecated. But if you use scanf and specifier s, it's also okay for me, right? So I don't you guys to worry about these kind of things. Like, spend your intellectual capacity in rather doing more sophisticated programming. Yanhao, when you use gets a, does it rewrite everything in a? Yes, it does, because it reads whatever it reads and then put it into a. Hara Sahib, for lab 1, does it matter if the GitHub autograder continues? Guys, please ignore the GitHub autograder for now. Don't worry about it. If you pass all the test cases in Eclipse, including the ones we give you, the ones you develop yourself, and you are sure that your code is correct, autograder right now has a problem because of the capacity of or the limit we have in GitHub, right? So ignore it. What means S? I forgot. I'm not sure if I got what you mean, Zawan. Arjun Snyder. What is the more computationally efficient, using gets and puts versus scanf and printf? This depends on how they are implemented internally, Arjun. So we don't know, right? So to answer this question correctly, you have to go inside the implementation and see which one operates better than the other, right? I would doubt that if they have any difference. I would guess from the like algorithmic running time point of view, they would be the same. Thanks. Okay, good. So I hope everyone is making good progress or almost done with lab 1, because this Friday is the deadline. And if you guys have any questions, please drop in the office hours, and we'll be pleased to help. See you all on Friday then.
May I ask one more question?
Sure, go ahead, you know.
1 second, I'm typing like.
Okay.
I can say it.
Sure,
like,
sure.
Like when you are doing a character a in bracket 20, like does the size limit include a /0?
It should. That's correct. When you declare the size of the array, you have to accommodate also the null character, right? Otherwise, this will be written into outside of the array limit, and then now you have a boundary leaking problem, right?
I see.
Yeah.
And also for the puts function, like does it just put whatever you put in the bracket?
Yes, because C doesn't do boundary checking for you. So if, for example, you define, and I guess we have done this example by saying if you define your array to be only 5 characters, while the user inputs, oh, you're talking about put, so not get.
Yeah.
What about put?
Like, does it just print whatever you put in the bracket?
It will only print what is in the array. That's correct. Because puts will check the array. That's correct. Yeah.
All right. Thank you.
Thanks. It will print, so just make sure it will print until it has the null character, right? Because maybe your array has a 0 in between. So similar to the example that we have seen for Canada and CEN. Good. Thanks everyone, and see you on Friday. Thanks.
Thank you.
Thanks. Bye-bye.